Behind the hood, beyond the arc, and past the sparks to talk shop with industry insiders who bring real-world experience and a unique perspective to every topic. This episode is sponsored by Fusion Grip TIG Torches, the Discover Welding online learning program, and by Florida Gas Welding Supplies. We appreciate their support in helping us bring real conversations and real industry insight to the welding community. All of our guests join us in their personal capacity, and the views they share are their own. This Weldcast exists to educate, inform, and support the welding community. References to tools, products, companies, or sponsors do not imply endorsement by our guests, their employers, or one another. Nothing in this Weldcast should be taken as instruction, technical direction, or engineering advice. Always follow the appropriate safety standards for your work environment, including ANSI Z49.1, ANSI Z136.1, and all manufacturer documentation, including owner and operator manuals. Only perform work within your training and qualifications, follow all warnings and labels, and seek formal instruction to advance your skills. Let's talk lasers. Laser technology isn't necessarily new, but who has access to that technology has been changing very fast, because what once used to live only in industrial settings with controlled welding cells is now showing up everywhere. Fab shops, repair centers, job shops, construction sites, even small manufacturers right around the corner who never imagined they'd be running a laser. And it's not just welding anymore. It's cutting, it's cleaning, it's marking, it's all kinds of applications that are being done with lasers. That accessibility is exciting, but it also creates a real challenge. The traditional industrial laser world has always operated in a strict world and a strict safety culture, with laser safety officers, controlled areas, proper signage, engineered interlocks, and proper PPE for optical and skin protection. But as these systems move into general welding environments, that structure doesn't always come along with them. And there's some key points. Laser radiation is not arc welding radiation. They are not the same. They don't behave the same. A laser does not look like a welding arc, and in many cases, you can't see it at all because the light is invisible to the human eye. The most dangerous part of the beam is invisible. You don't get the visual cues that you get from MIG or TIG welding or traditional arc processes. And because laser operates at the speed of light, you have far less time to react when something goes wrong. So the question becomes, how do welders, shops, and manufacturers adapt to this new reality? What safety controls matter the most? What PPE is actually required? And how do we guarantee that it's laser rated? And what should we be telling people who are looking to purchase their first handheld laser system? To help us break that down, I'm joined by my friend and colleague, David Werba from Miller Electric, a leader in product design compliance, a longtime contributor to AWS and IEC standards, and one of the most respected voices in welding and laser safety today. We're going to talk about the hazards that matter the most, the standards that guide safe use and safe equipment design, and the practical steps that every shop should take before they ever power up a handheld laser. Arc welding safety has always been serious, but with lasers, everything happens so much faster. There's less time to get it right and more reason to understand the rules before you start. Hey, Dave, welcome. Welcome to the podcast. We've overcome some technical difficulties and we're glad to see you on the other end of the screen here.
Awesome.
I have to thank you for your patience as I kick this off. So welcome, David. And tell us, what does everyone need to know about laser safety?
Thank you so much, Brent, for having me. I'm really honored to be here and to be able to talk with you about these very important laser safety topics. Yeah, so a main concern is the use of less experienced welders, and with that said, these welders still need to be educated, trained, and qualified to use the handheld laser welding systems, and everyone needs to know that the hazards of laser radiation bring new safety requirements that an electric arc welder did not need to be concerned about in the past, and that the use of this equipment and the techniques also bring new workplace requirements, such as the laser controlled area, the laser safety officer, of which we'll talk about more more in detail later.
Right, exactly. So we're seeing differences between arc welding and laser welding, and we need to be aware of those differences to take proper precautions. So fundamentally, what is a laser and what hazards do we need to be concerned about?
Yeah, so it's very interesting. So the word laser is actually an acronym. It stands for light amplification by stimulated emission of radiation. So, right, LASER. So the laser itself is a device that emits a concentrated, highly controlled beam, and they call it of coherent light through optical amplification. And in our industry, it is used to weld, cut, or etch or clean metal. From a safety perspective, although, the laser presents eye, skin, and burn hazards.
Oh, from what I understand, there's different types of lasers out there, lots of different types of lasers used in various industries. What type of lasers are used for welding or cutting?
Yeah, so as you just said, lasers are classified and their classifications are standardized categories. They range from class 1 to class 4. You know, the laser pointer pen you might see is a class 1 or 2 typically, but they do indicate the safety risk and the potential for eye and skin injury. And these factors are based on output power, wavelength, and emission duration of the laser. And in our case, the handheld laser beam welding equipment utilizes a high power class 4 laser instrument in order to melt the metal. And these class 4 high power lasers do present the most serious of all laser hazards.
So we're working with high-powered stuff, and we need to be concerned about that because they do present the most potential hazard. That makes sense. And you mentioned optical hazards or eye hazards, and I'm wondering, you know, I'm used to dealing with a welding arc and going maybe to a darker shade for more intense light and that kind of thing. But what's different between a laser light and a welding arc? And can I use the same hood for both of those?
Boy, absolutely not. You know, a standard welding arc, as we all know, it's electrical in nature, right? And the arc that is created between the electrode and the base metal basically generates intense heat due to the electrical resistance of that current flow. So that is what, you know, which melts the metal to create a weld. And the optical hazards from the welding arc in that case are in the ultraviolet or UV spectral range. And that can be mitigated by a much lower level of eye protection. But in a laser beam for welding, again, at the class 4 high power level, emits radiation in the infrared spectral range, the IR range. And that requires laser safety eyewear and laser welding helmets designed specifically to protect the eyes at the appropriate wavelength and optical density. So we must remember that exposure to laser light can inflict severe retinal and cornea injuries and damage, and it leads to permanent eye damage in a very short period of time. And that laser beam for welding is invisible to the welder as well.
Oh, wow. So that makes it even more dangerous because we can't see when we're being exposed. And by the time you do, it's too late.
Right. And maybe if I could add one thing too is there's a little bit of a misconception because a lot of the systems today use what's called a guide laser. So it'll be that type of laser pointer that you might see at a presentation, and people will think that's the actual laser, but the actual laser, the infrared beam, is invisible.
Oh, so they're putting a colored laser just so you can see it and help
So
you
you
track
know where
things.
you're pointing your actual laser beam at, right, to track it exactly.
Yeah, so when I'm arc welding, and I have unfortunately, like many, experienced some arc flash due to some errant arc rays, and you know it's kind of like a sunburn. After a few days, mild arc flash, it goes away. But what you're telling me now is with lasers, if you get laser flash, that could be permanent damage right from the get-go.
That is correct. I mean, permanent blindness if it's a direct hit to the eye.
Okay, so that just increased the level of intensity right there a lot from what we're used to with traditional arc welding shops. So where do these hazards exist then?
Yeah, so like we just talked about and mentioned, so the direct laser beams are the most hazardous, of course. But when laser beam welding in general, there can be scattered, direct, or laser beam radiation hazards that must be considered. For example, like highly reflective metals, they can produce a hazard if reflected beam by what they call a specular or mirror-like reflection. And the intensity of those reflections will vary based on the material type and the surface finish. So all of that, again, needs to be taken into account when using these systems. And we'll talk a little bit later about the LSO, the laser safety officer, that would be responsible for that in a particular situation or organization.
Okay, yeah, that's another interesting fact. So as we're dealing with shiny materials, and I have to say that metals jump right out there as a shiny reflective surface. So that's right there. We're dealing with intense power at a very focused level, and we're shining it on a reflective surface, which creates a high potential for hazards we need to be aware of and deal with.
Exactly.
What are some other examples of real world reflection scenarios that we might not anticipate happening?
That is a great question, Brent. You know, in addition to the reflection off of the top side of the parts, kind of like what we just talked about with reflective surfaces, you know, that most people might expect, you know, in a keyhole welding mode, the laser beam power can pass through the workpiece, and especially if it is required to capture the root of the welding process. So the result quite often is an eye or skin hazard, or the laser beam starting a fire to something else in the workplace or across the room, or, you know, a wall of a building or something like that. So that's one example. Another example of a real world unanticipated reflection scenario is when during the welding process, the direction of specular reflections might change based on part geometry. So in that example, the handheld laser beam welding operators must also be trained to understand that the changing hazards while welding actual production parts with more complex geometries than flat surfaces can occur.
Okay, so anytime you're doing anything that has different features that are coming out in 3 dimensions, it creates this prism, if you will, that could be reflecting beams in unanticipated directions. And from what I understand, some of those reflected beams could potentially cause some more serious issues than we might anticipate.
Absolutely.
So how does this compare to TIG welding? You know, being a TIG welder by trade and referencing most of my experience from TIG welding.
Well, you know, it's an invisible light, the actual IR. And, you know, really comparing to TIG, from a process standpoint, you know, from a production standpoint, it's a great comparison because you can see the advantages of the handheld laser welding, right? But really, no comparison should be made in the area of safety. The laser beam is just not an electric welding arc from the perspective of assessing those optical hazards that we talked about a little bit earlier.
Then my next question is, can laser radiation cause skin burns? You know, kind of like when we're arc welding, maybe without proper protection, we have some exposed skin. You may notice some sunburning. Would that happen with the laser as well?
So absolutely. And as I mentioned earlier, the laser actually presents eye, skin, and burn hazards. And the skin burns, you know, really all of your skin needs to be covered and protected by a flame resistant material when doing any laser welding. And it's, you know, if the beam is kept where it needs to be and the welding is done, you know, on the part and there are no reflections, you know, the risk isn't there. But the potential for that risk is always there if the workplace isn't assessed correctly.
Yeah. And it even if it doesn't show up today and maybe you did it fine yesterday, that doesn't mean the next time you run it, you're not going to run into a unique situation and potentially see a hazard you haven't before.
Yeah.
So let's talk beam reflections and unintended beam paths. So that's kind of an interesting thing that I've been reading about and learning about is this there's some situations could create higher risk. So what are the causes of these beam reflections and unintended paths, and how does part shape and adjacent surfaces, poor part fit up? I heard poor part fit up is something that we may not expect to cause the potential for an errant beam.
Right. So let me say for any setup situation where the handheld laser beam welding equipment is used, if it goes unassessed as to the understanding of the surfaces and where the hazardous reflected beams exist, that can create a high risk. You know, getting into the details about what are the causes, part shape, adjacent surfaces that you mentioned, poor part fit up. You know, causes of beam reflections and unintended beam paths can be part geometry. They can be also weld and torch angle management. There's some real good guidelines as to torch angles and minimizing the amount of reflections that might occur in unintended beam paths. But lack of tight joint fit up that you mentioned with what we call 0 to minimal gaps in fixturing itself can also be problematic. You don't want that laser beam, right, to leave the weldment and go somewhere else.
We're trying to contain that in that localized area as much as we can, because one, it does more work that way, and two, it protects people in the area, including the operator.
for
And
sure.
fixtures could be an issue too, I guess, that I was thinking about. A lot of the time we're working with fixtures that could introduce different reflectivity points, I guess.
Yeah, and depending on what they're made out of, they could be used as backing material to prevent, unintended beams from leaving the work area or the weldment.
Okay, yeah, so that makes sense too, by potentially dulling those surfaces and
Sure,
using some best practices there, we could minimize them as a potential source, which is interesting.
it
I
is. It is.
in the past I had heard about folks that used industrial lasers on stainless and aluminum would often have a painted or a film surface on there so it absorbed the light instead of reflecting it.
Sure,
Okay.
sure.
So what are the concerns with a reflected beam beyond the optical hazards?
Really, the concerns there are skin hazards and burning of the skin, but also fire hazards elsewhere. Like I mentioned, these potentially unexpected beam directions or reflections that still have enough power to light something else on fire in the area. And then the skin hazards, of course.
Sure, sure. And I don't want to compare this to my use of a magnifying glass as a youngster, but
Right.
it definitely comes to mind as we're focusing that power down. Ants would need to be scared.
Yeah, I think
So what
we
is
experienced that back in the day, didn't we?
we did. So a lot of these things, these principles, we can relate to other things in life, but some things are new, and in order to deal with the new safety perspectives and the hazards and proper precautions, what does shops need to do in terms of safety management?
Yeah, it's really a big part of this entire thing. Shops, organizations, they must have a documented laser safety program. They also need a laser safety officer, the LSO as it's called, and that person is appointed for assessment and the presence also of a laser controlled area, an LCA. So those are the big requirements for safety management. But additionally, users must also be able to assess the worksite prior to using the handheld laser beam welding equipment so that they understand the surfaces, like I mentioned earlier, where hazardous reflective beams can exist or come out of.
Right. So training is going to go a long way here. Um,
Definitely, definitely.
and organizational structure, you mentioned the laser safety officer, the LSO, and that was something that when I first got involved with lasers was paramount. That all places shall have one that's kind of in charge of deployment, if you will, and managing some of those hazard zones.
Yep.
So now let's take a look at a slightly different application. Let's talk about laser cleaning, which I know if I could use a laser and eliminate grinding wheels, I can see the benefit to that. But this application could present some additional risk, especially if it was misused. Is that correct?
Yeah, so in our experience, I mean, the most neglected item in the application that we just mentioned is an LCA. So a lot of times in laser cleaning, the lack the lack of the use of an actual LCA creates an especially risky situation. LCAs are required, and even if you can't have a permanent LCA for a specific location, a temporary LCA is required.
So when we're talking LCAs, just so that I can get my brain around that, is that something similar to an industrial situation where when I went out to a company, the laser was installed in its own room?
Yeah, so that would be typically, in the past, before the handheld lasers became so prolific and popular, that would be an automated laser situation with a specific laser cell with all the appropriate interlocks and all of the things that are required to prevent people from entering that type of area. So yeah, it's similar to that. It has some ability to allow people within it, but there are some additional requirements.
I gotcha. I gotcha. And that definitely makes sense with what you've been saying. So we can see why people love laser cleaning. What happens when someone, let's say, is outdoors and they clean a handrail with a laser?
Like you said, I mean, the loving the laser cleaning, I mean, it almost seems like it's happening by magic, right? It takes the surfaces, things off the surfaces so simply and so easily. We're getting into the situations when someone cleans, outdoor structures, handrails, things like that. it really gets down to, again, anytime laser cleaning is used, all the same precautions apply, safety precautions that you would use in any, whether it's welding, cleaning, or cutting. Especially when applying laser cleaning to items like the ones we just listed, handrails, outdoor structures, and public areas. They need to protect not only the user, but also anyone in the area from the laser hazards. And again, the use of that LCA is of utmost importance, where you might have bystanders or onlookers present in the area that you wouldn't normally expect if you're in a production environment.
Exactly. A little bit unpredictable out there on the construction site, if you will. So a little bit off script here. So if I'm going to protect people in my welding area, I might use welding curtains or screens. They're
Sure.
typically some type of a transparent material so you can see what's going on. But would those kind of things be suitable for laser? Or again, like a laser helmet, do they have to be specialized?
Yeah, they have to be specialized. Those transparent welding curtains or screens that we're also familiar with, they protect, and they're designed to protect in the different areas of the spectral range, again, of the optical spectrum. And that's basically so passersby can see what's happening in there, but not be have damage occur to their eyes. In the situation with the laser welding beam, again, it's in the IR range, not the UV range. So it ends up being way too high of a intensity, power, and distance factor for any of those transparent welding screens.
Okay, so they're not going to be effective for this. It's
Unfortunately not. No.
Rewriting the whole rule book.
Yes.
Yeah. So what else would you like a shop to know before they let their employees start doing laser cleaning out in the middle of a production floor, or maybe out in a construction site?
Yeah, so as with all processes, and what we always recommend initially, they must read and follow their equipment manufacturers, equipment labels, the safety precautions, and the instructions, and then any applicable safety standards. And later on, when we talk about the standards and where they're headed in this area, I have a lot of good resources for those applicable safety standards. But they really need to, not only shops, but owners, managers, and employees need to know what is all required from a safety perspective.
Absolutely. Now, I'm thinking about other hazards that we deal with arc welding, and we often experience a fume plume, and we want to have good ventilation. How's laser going to compare to, let's say, TIG fumes?
So right now there are some studies underway by different researchers around the world. I'm aware of it through my affiliations and chair positions with the different International Institute of Welding and American Welding Society, and some of the work that's being done there. But right now I'm not aware of any differences as regards to being compared to TIG fumes. We believe there's less, but not differences at this point. But it's still ongoing research. So again, everyone must know that when you're welding, it produces fumes and gases, and breathing those fumes and gases can be hazardous to your health. So it's all about ventilation that you just mentioned. So, you probably can't say standard welding ventilation is sufficient. It's just a broad blanket statement because it can't be adequately addressed with a simple answer. Really, the only way and the recommended way is to determine if adequate ventilation is to sample for the composition of the quantity of the welding fumes and gases, to which your workers are exposed or your welders are exposed.
Okay, and that would be along the lines of industrial hygiene, or an industrial hygienist may measure that and then determine if ventilation is adequate or not. And so many factors go into that.
Absolutely. And our recommendation is to always, if you're unsure and not aware if adequate ventilation is achieved, call in a certified industrial hygienist and have them test the air to determine.
Yep, it's really the only safe way to know moving forward whether you're protected or you need more.
Exactly.
Now, from what I understand, I've seen some light tight enclosures and some of the, what I'm going to call the higher end, if you will, the handheld systems, where we're doing this in a very tight booth to protect bystanders and that kind of thing. How does fumes and ventilation come into play when you're in an enclosure like that?
if they're done properly, that enclosure would be considered an LCA, right? But an
Yes.
enclosure, as in any situation, would be part of that determination we just talked about of adequate ventilation. So, again, the recommended way is to sample for the composition and quantity of fumes, but it would not change in an enclosure. It would just be considered that would be the area under determination.
Is there any red flags, if you will, where we know extra ventilation is going to be required?
Well, the simplest red flag is likely, welding fume that's in the breathing zone of the welder. That's the most simplest thing. But again, it really needs to be taken on as a industrial hygiene project and determined, what needs to be done.
Dave, a couple of years ago, I went to the FabTech show, AWS show down in Chicago, and I saw this big push and lots of new products being introduced in the handheld spectrum, and it's kind of what we've been talking about is changing the game of traditional industrial LCAs and laser installations compared to now I can take this thing out and use it basically where you would never see a laser used before. So in terms of PPE, what PPE is again required, and why does TIG PPE not necessarily work in all cases when we switch over to a laser?
Why it doesn't work comes back to what we talked about earlier, the light spectrum and the wavelength of which it is at, and then the optical density of it. Whereas, again, in TIG welding, it's an electric arc welding process, and you're really just getting those UV rays that we all know about, and we experience, some slight arc flash or some, the sunburn type of effect to skin. These lasers, need their own specific personal protective equipment or PPE. Laser safety eyewear is mandatory. It's designed to protect for the specific wavelengths and optical densities. And same thing with a laser welding helmet. And then heat resistant gloves and flame resistant clothing. There's a lot of work still being done in the area of gloves and clothing, but those are what are required at this point in time.
It's interesting. You just made me think of something, right? Because I've often taken my standard number 10 lens and I can MIG weld, I can TIG weld, I can stick weld, I can use it on lots of different machines. And in this case, when I have optical eyewear or a filtration device, it's dedicated to that at least type of laser.
That is correct. Absolutely.
Based on wavelength.
Exactly. And what people misunderstand and what everyone must understand is that standard safety eyewear, standard safety glasses, even shaded glasses, and standard welding helmets at any shade do not provide adequate protection from the laser beam hazards, as we've been talking about earlier. It just doesn't have the protection level.
Even a shade 15, if I buy the darkest shade, it's not going to do what I need it to do to protect me from the laser.
No, it will not.
So how do I select the right laser helmet or the right laser eyewear to protect me?
Yeah, so selecting laser safety eyewear and laser welding helmets, first of all, follow the equipment manufacturer's recommendations. If you're buying good quality equipment, they will have recommendations and they will give you the appropriate wavelength, and they will also give you the optical density numbers. That way you can match your safety eyewear and your laser welding helmet to the exact wavelength and optical density. And it really is the only way to verify that you're protected, that the equipment you're using is designed to protect you against both direct, reflected, and scattered laser beams and radiation.
Yeah, direct, reflected, and scattered. So it's coming in multiple forms, and we got to be ready for it. And I like what you said there. In my discussions in the training and teaching that I've done, I always start with the manual and the manufacturer recommendations because, like you said, quality manufacturers are going to provide that guidance, and that's going to get you in the ballpark. So work with your suppliers.
Always recommended.
We're kind of spoiled with arc welding because one, we've been doing it for so long as an industry, right? That there's lots of knowledge out there, and lasers are all of a sudden coming super fast. They're super new, and they are completely different than what we're used to. So I feel like I'm getting re-educated here.
The most experienced, as some of us, been in the industry for 35, 40 some years, We think we know everything that is necessary to know about the safety in the welding environment. And along comes this new device, which works wonders from a production and a productivity standpoint. And we have to relearn about the safety of the actual optical hazards.
Yeah, it's so ironic that the beam is invisible, right? So
I know it's counterintuitive for sure, but
it is. It looks harmless because you can't see it, but boy, it's right there. Kind of like electricity, I guess.
I was going to say, think about it in the same way you think about electricity.
Never touch it.
Very harmful if touched, but you can't see it.
Right, exactly. So, in terms of protective clothing, I'm used to wearing cotton and wool and the FR rated stuff, covering all my skin. Right when I started out welding, we used to pretend we were tough and we didn't need all that, but we've learned over time that that's important to protect your health. So, what type of clothing is suitable, and is it different from welding?
It's not totally different. Like I said, there's some research being done to maybe increase the levels of protection with the clothing and gloves, for example, as PPE. But the real rule is that any exposed skin shall not be in the vicinity of the laser beam. It's quite similar to your standard electric arc, but the severity of the skin damage that can occur is much higher and much faster with the laser beam than the standard electric arc welding. So again, heat resistant protective gloves and clothing must always be worn. And remember that for class 4 lasers, once again, no amount of PPE can provide complete protection. It needs to be engineering and administrative controls need to be used with the class 4 lasers, and that way preventing the stray beam that might vary from or leave the area where you're actually welding.
Aside from PPE, we can look at engineered controls, and that's something interesting. What should a quality system have in place in terms of engineered controls that make sure that I can't misuse this equipment or I can't use it wrong?
So from a organizational standpoint, we touched on it a little bit already, but there's really the rule that each organization or even any sole operator operating outside an organization using this type of class 4 laser, they must appoint a qualified laser safety officer or be trained on that. They need to have that documented laser safety program, and they need to have a laser controlled area, and that's important for each point of use. So beyond that, we get into what kind of controls we can have in the equipment itself from an engineered standpoint. And in addition to the quality system that I just mentioned, there are several things that can be actually designed into the equipment to make sure that you are avoiding the safety hazards that might be present.
What type of engineered controls are mandatory in terms of a quality system like that? What should it have?
Yeah, so there's a few standards out there. One's in the ISO world and one is in the IEC world. But on the equipment side, users and buyers of the equipment must ensure that the equipment incorporates these important built-in safety features. And there's really 3 that are absolutely required. And then there's others to consider as well. The first one is a key switch. So you can secure the equipment and control unauthorized operation of the equipment. The second one is emergency stop button. We don't typically experience that in electric arc welding on the equipment at all. And that is to be able to terminate the laser emission immediately with the e-stop depression. And then the third one is connection for an external interlock. And what that really does is shuts down the laser emission if someone other than the operator unexpectedly enters the LCA. The LCA actually needs interlocks on the doors to the LCA to shut down the laser if someone enters. And then a few of the other items that are really important to consider, and some of them are required by the ISO standards, the International Standards Organization. The first one there is a 2-stage torch trigger, and that's to prevent unintentional laser emission. And it includes a visible laser ready indicator and a laser emission warning device. And it's always in the field of vision of the actual operator, so it's on the torch itself. And then a workpiece contact circuit. So the workpiece contact circuit basically only is enabled when the torch tip is in contact with the work itself. Even beyond that, Brent, there's two other, I know I'm getting kind of deep into it, but
No, that's great though.
yeah. Two additional features that you really should consider is the fact that some local regulations require it. Also, that after the start of a weld, you have an actual plasma sensor. So if the plasma is not formed upon the beginning of the weld, after a very short time, usually milliseconds, it will deactivate laser emission. So it knows then that you're pointing the laser at something, you're activating the trigger switch. It is starting to emit laser, but yet it hasn't formed a plasma, so it knows that, and that way it'll shut down the laser emission. One more thing, I'm sorry to be so belabored, but also another thing is the fourth feature is another interlock, but it's an optical interlock circuit in the actual fiber optic cable set. Because as you can imagine, we're not using an electrical cable to go from the handheld laser beam welding power source to the actual torch. We're using a fiber optic cable, and if there's any integrity problems with that or any problems with that, it'll shut down laser emission also or again. So sorry to be so belabored, but those are some really cool equipment features.
No, you brought up some really, really good points. And when I think now, you'll have to remind me, I don't want to forget anything, but that interlocking dual stage trigger, is that going to be similar to what I've seen on a plasma cutter where I have to flip it in two directions and I can't like set my MIG gun down and have it automatically kick on, right?
Yeah, it's very similar to that. Exactly.
Okay, so that I'm familiar with, and that makes sense. And you said something else with the continuity test. So we do have what we're not going to call it a work clamp, I guess, but maybe that's what it's called, where we're making a contact, and when the laser or the device is in contact and senses continuity, that's your first kind of go stage that says you're ready to rock.
Yeah, you
But
are correct.
that plasma piece, plasma detection. So if someone was to somehow figure out a workaround to get the beam to fire, how long does that plasma detection take to kick in before it would say, "Hey, we know you're not welding. We're going to shut you down"?
Well, all systems can be slightly different in their design, but it's usually milliseconds. So it's a very short duration, and hopefully it prevents any sort of misguided beams of the laser itself, because plasma has not formed, and that means you're not welding or cutting or cleaning.
Yep. Whether that's accidental or because of
Or
shop.
intentional or some way, or yeah.
Yeah. And it's designed to protect the user and people around it. So that's interesting. I learned something new there. And I think that plasma detection is kind of a neat resource that I haven't heard of in a lot of arc welding applications yet.
Right.
What does a proper enclosure look like when I'm going to employ one of these handheld systems in a shop or on a job site?
Yeah, so we talked about it already. Just from a naming convention and standpoint, proper enclosure is officially called an LCA, or a laser controlled area. As you mentioned it earlier, you've seen some of those similar things where you have a light tight enclosure. So it must be a light tight enclosure. It must have laser blocking panels. It must have, like I just mentioned, an access door with interlock switch, or more than one interlock switch if there's more than one door. And it must have a laser on warning sign and or a light to indicate that laser is occurring inside the LCA. It must also have an information sign on the outside of the LCA, and this would list, just from an informational standpoint, the maximum laser power and the wavelength, and then any barriers or windows used in the LCA, they shall also be made of laser safe material so that they can withstand direct and reflected beams.
Okay, so this is going to be highly engineered, and again, going to be dedicated to the power of the laser and the wavelength that it's producing.
Correct.
Okay. So how do we handle fume extraction into this type of a system?
Yeah, so as the LCA, I think I mentioned earlier when we talk about enclosures in general, the LCA is considered as an enclosure. It would be completely part of that determination of adequate ventilation again. And of course, the recommended way is to sample again for the composition, quantity of fumes, and so on, which a person may be exposed to. And then, if you want to talk about fume extraction itself beyond that, if it's necessary, each location again needs to have an industrial hygienist. They need to test the air and determine if additional fume extraction or filtration is needed, and to make sure that they're providing adequate protection, from any of the contaminants in that environment in the LCA or enclosure itself.
Okay, so this is again goes back to sampling, monitoring, making sure that we're staying up with things and knowing what we're walking into, so to speak, in terms of how we're going to implement this safely. So, what are the installation requirements that a shop might overlook and think, hey, we've got all of our ducks in a row. We're going to put this laser in. We'll be welding by 2 o'clock this afternoon.
Sure. Yeah, so for us and for me and for what I've seen, the most common installation requirement that's overlooked is the connection of that door interlock to the laser welding power source, to shut off the laser emission if that access door is open to the LCA. That's the biggest one we see quite often. You can, like with anything, you can bypass the connection to the welding power source by jumping out those connections. I don't want to give anybody any bad ideas, but if that's what you do, you can still run the laser power source, and it will think that the interlocks are in place. So, and then another commonly overlooked item is the top, or what I might call the roof of the LCA. You might not think about this, and a lot of people overlook this, but for overhead personnel and or other welders, or just anyone that might be on the next story or the next level of a construction site, for example, they may not think they need a top on that LCA. And or the side panels are another one, because some LCAs are designed because no one will be viewing from the underside, for example. They may have panels that don't go all the way down to the floor, and therefore they're not providing a laser tight enclosure. So those are some of the overlooked items that we hear and see about in the process at this point.
Dave, those are huge because all the shops that I've gone in, I got to tell you, aside from an automated application where there was actually a top on a robotic cell with fume extraction built in, I see handheld booths that basically just have screens. They never have a roof and they never go all the way to the floor. So that's a big change from what we're used to.
It's a big change, and it's where we really, once again, educate, train, understanding. But that's what has to happen in our industry.
Yeah, absolutely. That gives us something to think about. I know I'm going to be thinking about this long after our discussion today, and probably right as a welder and having that mindset. Every shop I go into, I'm going to be doing this assessment in my mind, especially if I see that light that says laser in use.
Right. Yeah, definitely. Know where that's happening, and avoid that area unless you're fully PPE'd with the same thing the welder would have on, and you're allowed and cleared to go into that LCA.
Yeah, that's a good point too. You don't want someone accidentally walking into an environment where, one, there's invisible beams, they don't know the hazards, and
Right.
at the same time, these things happen at the speed of light, so it's relatively quick.
Yeah.
All right. So from an organizational standpoint, we've talked about some of the things that a shop should have, especially the laser areas and the laser safety officers. What other policies should we have in a shop before we install a laser?
It all comes down to having a documented laser safety program. And from what I've seen, if you are becoming trained as an LSO, qualified as an LSO, you will also understand what a laser safety program needs to include and entail. And it may be specific, to every point of use, because each thing might, each area might be unique and have its own special qualifications. But again, you need an LSO, you need to have this laser safety program documented, and you need to have an LCA, the laser controlled area, for every point of use.
Do you see this evolving as we go and maybe changing given what we know about handheld lasers today?
I don't really see that changing. What I just mentioned, that is outlined quite well in an ANSI standard, of which I can give reference to. We can provide for the listeners. But I don't see that changing. I think that's pretty solid in the way of the training, the understanding, and the requirements for the organization.
Okay, and specifically, if I'm training my operators, are there some top things they need to know and need to be trained on?
Yeah, I mean, for sure, an LSO is different than the welder or operator itself. So we don't want to confuse, if you're not going to be the LSO for the organization, but what the welder must really know is everything that the LSO is prescribing to them for a particular LCA or an enclosed laser area. And then they need to, like I said earlier, be able to assess part geometries and the actual welding that they're doing, and it may be defined in their WPS, but essentially they need to understand where these laser beams might be reflected and might go from a safety perspective.
I can see being used to arc welding being very localized. If the beam path isn't anticipated and we don't think about those things, then it could have some unintended consequences, unintended pathways that would create additional exposure potential. So, what documentations and procedures should be in place besides the laser program?
Again, that's it really. And
Oh,
also, what have your LSO in place. The procedures of how you're going to assess each LCA needs to be in place, and the LSO needs to be responsible for your organization for any of those LCA locations.
and so then would the LSO be the person in charge of safety assessments or hazard assessments?
Specific to the laser operation, yes.
Okay, okay. What would a proper hazard assessment look like?
Well, like you just mentioned, it is the responsibility of the LSO. It'll be conducted by the LSO. And what it really comes down to is evaluating all beam and non-beam hazards and ensuring that every operator and observer that uses lasers or is exposed to lasers has the information and training on the safe use of the equipment and the potential hazards.
Okay, so training is going to be key here as we re-educate our workforce about
Absolutely.
about this new technology, and handled properly, I'm sure it can be used successfully and safely as it has been for years.
There's no question about it. It's just now it's in your hand. Now it's being manipulated by a person. It's not an automated process controlled within an area where there are no people. And that's why all of these safety precautions need to be followed.
Yep, because it brings a new set of potential into the game. So,
Exactly.
where is laser safety going, Dave?
Yeah, so the safety standards development organizations and the standards themselves they're really advancing at a rapid rate, and it's really to keep pace with our industry, as you know, and the reason we're talking about this is this process is becoming so prolific throughout our industry. So really, that's where the safety of it also needs to go. And there's some new developments also in the area of guidance documents.
Oh, so you mentioned the organizations ISO, ANSI. Right, I'm used to Z49.1. What's the document that might guide me to safety for lasers? Is there a similar document?
Yeah, so actually, the Z49.1 is in a rewrite right now. I'm actually the chair of that committee, and we have a good list of proposals to add handheld laser welding safety items to that. So that will be coming out within the next year or so. But the other standards that are already in place and published, there's an American National Standards Institute, an ANSI, and it's a Z136 series of standards. For example, part one is safe use of lasers in general. Part nine, for example, is safe use of lasers in the manufacturing environments, which applies to some degree for us. And then the very similar, almost like a mirror standard to the ANSI Z49 that we just talked about. Up in Canada, there's the CSA, Canadian Standards Association. Their W117 standard has been updated just as of this past end of 2025, and they added sections on handheld laser welding safety as well. And then on the equipment side of it, I mentioned earlier, there's a couple of IEC and ISO standards that touch somewhat on those safety features I mentioned for the equipment designs.
Okay, so these standards have been evolving very recently here.
Yeah,
Oh,
definitely. Those of us in the industry that see this great use of these products and the lack of the right information out there for everyone have been stepping forward and really kind of taking the bull by the horns and starting the work on these rewrites of these standards to include the handheld laser beam welding safety.
yeah, I know that one triggered some concerns with me when I first saw it, and especially the lack of enclosure and kind of that lack of PPE that some people were using during demonstrations.
Sure.
I knew that wasn't right, based on what I know about a Class 4 laser. No,
Exactly.
so seeing this education come out, seeing these standards lead the way, I think is spot on, because one of the things I've noticed talking about lasers with folks lately is there's a lot of misconceptions out there. Both good, bad, and indifferent, right? Some people say it can't hurt you. Some people say it's extremely dangerous. And what I'm finding is with proper precautions, with proper education, we can minimize the risk and we can do this successfully. And that's going to be the key.
Exactly.
Fantastic. So where can people look to find the latest in emerging safety updates and new technologies, new PPE, that kind of thing?
Yeah, just to hit on a few. So, when we saw the need back in 2024, American Welding Society Safety and Health Committee, we authored a safety and health fact sheet, a new one, number 46, which is handheld laser welding safety. And it's free on aws.org, and we can give all these links out to everyone. But it is a great couple page resource of a lot of the things I just talked about, the requirements and why they're necessary and what the hazards really are. Additionally, through the International Institute of Welding, IIW, we wrote about a 39-page considerations about handheld laser beam welding. And it does not only cover safety, a good section of it is on safety, but it also covers some process requirements, some qualification ideas, different things. And that actually document is also free and available through International Institute of Welding. And we are in the process of a rewrite on that as well for this year. So that will get more added information in the area of qualifications and process. And then one last new thing that we're almost ready to release is through the Laser Institute of America, LIA. It's a handheld laser welding safety card. Really cool, kind of like you'd see, on an airline flight in the back seat of the seat, where you'd have a laminated card. It's just going to be 2 pages, but it's going to tell you, and it's going to be really cool the way it's organized. It's going to tell you, what do I do before I buy my equipment? What do I do before my very first use of the equipment? What do I do every time I'm using the equipment? And what do I need to do post use of the equipment? So that will be available free as well through the Laser Institute of America. So some really cool happenings out there with latest safety updates in this area.
Yeah, there are. It sounds like a lot of free resources out there that we will provide links to in the description to get people to the right places so that they can proceed with a plan and educate it and of course implement safely. So that's awesome. Awesome to hear a lot of that work. And it sounds like you're pretty directly involved with a lot of that work.
Yeah, we got to do the right thing for the industry, and that's where we're headed. So.
Yeah. Well, we certainly appreciate it. I know I'm glad to have folks like you working on this out there and making sure that these implementations are safe. So, Dave, in closing, when a shop is evaluating a laser provider or looking at a system, what should they look for from a safety standpoint? Beyond the labels, the bells and the whistles, what should they really be thinking about?
Yeah, the way I look at it, Brent, is a laser provider that you want to look at and you want to consider really needs to have the right support in the area of the safety material, for example, videos and support that they give you from understanding all the aspects of the use of this equipment. And you want to look at that organization and possibly understand, do they support and participate in the development of these safety standards that I've been talking about and the supporting material? Because they can really be the experts. They're designing the equipment, they know the industry, and they're able to provide the best support to the standards development organizations that are working on the requirements. And also, I would say a laser provider that has the product offering to cover all of your needs. Really kind of a one-stop shop for all things handheld laser beam welding. That would be my take on it at this point, right?
Soup to nuts, look for a system that's designed with implementation, safety in mind, and then make sure that the company you're working with has that expertise and provides that guidance for you. They don't just give you the tool and say good luck.
Yeah, very much so.
Yeah. Well, Dave, I sure appreciate your time. It was fantastic to hear from your side of things, how safety is evolving. You've given us a lot of information on things we need to be aware of, hazards that are out there, proper precautions, and how we can engineer safety into our products. And I'm hoping that this helps to clarify some of the misconception of laser safety out there.
Absolutely. And also, I thank you again, Brent. The opportunity and the ability to help educate and train and get this information to the industry is of utmost importance to me and my organization. So thank you very much.
Hey, you're welcome. I hope that we can get together again and continue our conversation. And until then, I wish you safe travels, safe welding.
Same to you, and thank you again.
All right.
Take
Thanks,
care.
Dave. As we wrap up our discussion, the takeaway is simple. Make sure your setup follows industry guidelines with appropriate laser-rated PPE, laser-rated enclosures, and laser-rated controls. These aren't optional. They're mandatory if you want to protect the operator, bystanders, and others in the vicinity. There's more to come on laser safety, and I'm genuinely looking forward to the updated ANSI Z49.1. Because that's always been the safety standard that I followed, and having that in there as a free download from the American Welding Society is a huge asset to our industry. And a huge thank you to Dave and other experts who donated their time to develop these important standards. Because of their work, we know what to look for in a quality system, and we know how to safely implement that technology into our operations. Whether you're a small one-person shop or a large manufacturer, it all comes down to some simple, basic things: training, awareness, and proper precautions. So until next time, stay safe out there, keep your hood down, and don't stare at the invisible light. Thank you to our sponsors, Fusion Grip TIG Torches, the Discover Welding online learning program, and Florida Gas Welding Supplies, for supporting this Weldcast and helping us bring these conversations to the welding community. If you're following our laser welding series, stay tuned. We've got more episodes coming with professionals who work with these systems every day. Our goal is to cut through the noise, talk honestly about the technology, and how these tools can fit into a modern operation. Thanks for watching the Sparks and Spatter Weldcast. I'm Brent Williams. We'll see you in the next episode.